Hey guys, this is Miss Smith. We are continuing on with Unit 2, moving straight ahead. Today is Lesson 5, solving two-step equations. In this lesson, you will learn how to solve equations which involve two operations. These types of equations require using two inverse operations in succession to solve. They are called two-step equations. Our essential question for the day is, how can I solve two-step equations? This is a little comic. It's pretty funny. I think you should be more explicit here in step 2. And in two-steps equations, you have to show all your work and make sure that you keep everything nice and neat. All right, solving two-step equations. We're going to use our knowledge of one-step equations to help you solve two-step equations. Remember, your goal is to isolate the variable. Get the variable by itself. First, we're going to start on the side with the variable. You always start on the side with the variable. Then we're going to get rid of the number that is furthest away from the variable by doing our inverse balance solve, or our IBS. Step 3, we're going to get rid of the number closest to the variable by again doing inverse balance solve, or IBS. Then we're going to check our answer. And this is a big one. You got to check your answer. And the way you do that is you plug in your answer into the original equation to see if both sides equal each other. So, like in one steps, we did inverse balance solve and we were done. Well, in two-step, we have to do inverse balance solve, inverse balance solve. So it's 2 times that we do that. These are just some examples of what two-step equations can look like. There are many different ways that they can look, but this is one of them, or a few of them. All right, so let's try some. Just like with our one step, we want to divide our problem into two sides. So the equal sign actually divides our problem up into a left side and a right side. Now, if you remember from your notes, the first thing we want to do is isolate the variable, or our end result is to isolate the variable. So we want to start on the side with the variable. So here we are, we're starting on the left-hand side in this case. Okay, so that's the side with the variable. The second thing we want to do is get rid of the number furthest away from the variable. So I have a 5 and he's attached to the variable. He's holding on. So this 6 is furthest away from the variable. So I'm going to do IBS. Inverse balance then solve. So what is the inverse of subtracting a 6? Right, adding a 6. So I'm going to add 6 here, and what that does is now I have a negative 6 and a positive 6, which gives me a 0. It cancels each other out, which is what I want. I want that to go away. Now, if you know in math, what you do to one side of the equation, you have to do to the other. So I am actually going to add 6 to the right side as well. That keeps my equation balanced. So what I do to one side, I have to do to the other. Now, I'm going to come over to the side of my paper and rewrite this as negative 21 plus positive 6. Now, we have to remember our rules for integers here. We have a negative 21 and a positive 6. Are the signs the same? No, so we're going to subtract. 21 minus 6 gives me 15. Now I'm not done because I got to take the sign of the largest number. The larger number is 21 and its sign is a negative. So this means that this answer is going to be negative. So this gives me a negative 15 on the right hand side. The equal sign just falls down and this 6 is out of the way. So now I just have 5x. Now, on one-step equations, we would be done. But now, I still have a number that's attached to the variable. So I've got to get that variable all by itself. Well, what operation is being done to the number and the variable right now? Right, multiplication. 5 is being multiplied by x. Now, in order for me to do the inverse, I got to do the opposite. Inverse and opposite are the same thing. So I'm going to do the opposite of multiplication, or the inverse of multiplication, which is division. So I'm going to divide both sides by 5 because we have to keep that b in there. We have to balance. So what I do to one side, I have to do to the other. Now, what happens here is these 5s, they cancel each other out. And I'm left with x on the left side, which is perfect. That's what I want. I want x all by itself. Now I have to solve this side. I have a negative divided by a positive, so I know my answer is going to be negative. And then I have 15 divided by 5, which gives me 3. Now, the last thing, which is probably the most important, I have to check my answer. So I'm going to take my original equation, 5x minus 6 equals negative 21. And remember in lesson 3, we learned about substitution, substituting in. So I'm going to take what my x equals and I'm going to substitute it in down here. So I have 5 and x equals negative 3 minus 6 equals negative 21. I have a positive 5 times a negative 3, which gives me a negative 15. Minus 6 equals negative 21. Anytime I see subtraction, I'm adding the opposite. I have a negative 15 and a negative 6. The signs are the same, so I add and keep. So that'll give me a negative 21. Now, at this point, I should see both sides should equal each other. If my answer is correct, then my left side will equal my right side, and that includes the sign. Do not forget the sign. So does negative 21 equal negative 21? Yes, it does. So that means that my answer was correct. So x equals negative 3. Let's look at example number 2. Again, I'm going to split my equation up into two parts, or two sides. I have a left side and I have a right side. And the first thing I want to do is start on the side with the variable. So I go where I see my variable. Here's C. Here's my variable. So this is the side I'm starting on. I'm starting on the left-hand side. Second step is to get rid of the number furthest away from the variable. Well, in this case, it's adding 13. And in most cases, pretty much all cases except for one special case, which we'll talk about, you always, always, always get rid of addition and subtraction first. Except for in the one special case, and we'll talk about that in a minute. But here, they are adding 13. And I want to do the inverse. In order to get it to go away, I have to do the inverse, or the opposite. So if they add 13 over here, I want to subtract 13 in order to get rid of it. Okay, so those cross out because I have a positive 13 and a negative 13, which give me 0, so that goes away. But the B, remember, stands for balance. So what I do to one side, I have to do to the other. So this side, I'm going to subtract 13. Now, I'm going to come over to the side and do my scratch work. I have 0 minus 13. Anytime I have subtraction now, I add the opposite. So I have a 0 and a negative 13, which just gives me negative 13. The equal sign just slides down, and then I bring whatever else is left down. So I have C over 3. Now, is my variable all by itself? No, so I got to do the whole process over again. I have to do inverse, balance, and solve. Well, first I have to determine what is being done to my variable here. Well, C over 3 also is the same thing as C divided by 3. So what's the inverse of division? Right, multiplication. So I'm going to multiply this side by 3. And what happens here is if I put this over 1, you'll see we can cross cancel our 3's. So this 3 and this 3 go away. I'm just left with C over 1, which equals C. Now remember, what I do to one side, I have to do to the other. So I want to multiply this side by 3. I have a negative times a positive, which gives me a negative number. Always put your sign first so you don't mess up at the end. Then I have 13 times 3, which gives me 39. Well, I don't know if that's 100% correct yet, so let's go plug it in. I had C over 3 plus 13 equals 0. So I'm going to plug in my answer, the one I got. I got negative 39 over 3 plus 13, and I want to see if it equals 0. All right, a negative divided by a positive gives me a negative number. I know that 3 goes into 39 13 times, so I have negative 13 plus 13 equals 0. A negative plus a positive means I'm going to subtract. 13 minus 13 is 0, and 0 is not positive or negative. So does 0 equal 0? Yep. So that means that my answer up here is correct. All right, let's look at example 3. Now, remember when I was talking about you always get rid of addition and subtraction first, except for if there's a special case? Well, make a note, because this one right here, number 3, is a special case. And you need to remember that any time my equation looks like this, it's special. And I'm going to do something differently than I have been before. All right, so the first thing I'm going to do is split up my equation into two sides. Now, here, this is different because 5 plus x is all being divided by 6. And it's not just 5 over 6 or just x over 6. The whole thing is being divided by 6. So in this case, and in this case only, I've got to get rid of this division bar. Well, what's the inverse of division? Right, multiplication. And what are they dividing by? 6. So I'm going to multiply by 6. And you can do this 6 over 1. Now, if you notice, what happens here is that these 6's, I have 6 over 1 times 5 plus x over 6, the 6's are going to cancel out. And that will leave me with 5 plus x equals, now what I do to one side, I have to do to the other. So I have to multiply this side by 6 as well. All right, that's the balance. Then I have a negative times a positive, which gives me a negative, and 1 times 6 gives me 6. Now I still got to get my variable by itself. And what is being done to the variable right now, what is keeping it from being isolated, is a positive 5. Okay, I'm looking just at the number. 5 is positive. So I want to do the inverse or the opposite of positive, which is negative. So I'm going to subtract 5. Then I have a positive 5 and a negative 5, which gets rid of that. So I'm left with just x on this side. Now if I subtract 5 over here, I've got to subtract it over here. I'm going to come over to the side. I have negative 6 minus 5. And it's important that you come over to the side and write it horizontal, because sometimes you'll miss this. Because what happens here is I have subtraction, so I have to really add the opposite, which makes both of these numbers negative. So I have a negative 6 and a negative 5. My signs are the same, so I add and keep. So that would give me a negative 11. So I have x equals negative 11. Well, we need to plug it in just to make sure. So I have my original problem. I have 5 plus x over 6, all over 6, equals negative 1. All right, so I'm going to plug in x. I have 5 plus, I'm saying that x is a negative 11, all over 6 equals negative 1. And I'm running out of room, so I'm going to come over here. So I have a positive 5 and a negative 11. Signs are different, so I'm going to subtract. 11 minus 5 is 6. Take the sign of the larger number, so it is negative. And then everything else I'll just keep as it is. Now I have a negative divided by a positive, which gives me a negative. 6 divided by 6 is 1. Does negative 1 equal negative 1? Yes, it does. So that is correct. And so my answer was x equals negative 11. All right? Remember, when it looks like this with the number and the variable all over a number, that is a special case. So make sure you remember that special case. All right, example number 4. Now we're going to take some things that we've already learned, like distributing and combining like terms, and we have actually got to do those before we solve our equation. So, for example, in number 4, we still split up our equation into two sides. Now, if you notice, the variable's on the right-hand side. But before I can even start solving for the variable, I've got to do the distributive property first. I've got to simplify this equation, or this side of the equation. So I'm going to do distributive property. And remember, I take the outside number and multiply it by everything on the inside. So 10 times x gives me 10x. And then 10 times 5 gives me a 50, so plus 50 equals my 128. All right, now this looks like a two-step equation. Both sides are simplified so that I can go ahead and start my two-step equation. Now, this is not a special case, so I know I'm going to get rid of addition and subtraction first. In this case, we are adding, so I want to do the inverse of adding, which is subtracting. So I'm going to subtract 50 from both sides. I have 128 minus 50. 8 minus 0 is 8. Borrow from the 1, that gives me 12 over here, so that gives me 7. So 78 equals 10x. My variable still has a number attached to it, so I have to do the inverse of what's going on over here. I have 10 times x, so the inverse of multiplication is division. So I'm going to divide both sides by 10. These 10s over here cross out, and I'm left with x, which is what I want. I want my variable by itself. Now, 78 divided by 10. Well, if you remember your tens rules, that if I'm dividing by 10, I'm going to take my decimal and move it over one place to the left. So I have 7.8. If you didn't know that, or if it's not 10, all you got to do is do top dog goes in the house. So 78 goes inside the house, 10 goes outside, and then I just divide like normal. Add a decimal, add a 0, decimal comes up, and then 10 into 80 is 8. So I get 7.8. Now, if we want to check our work, I take the equation after I distributed. So I got 128 equals 10x plus 50. And what I can do is plug in x. So 128 equals 10 times what I got for x, which was 7.8, plus 50. So I get 128 equals 10 times 7.8. Just move that decimal to the right. That gives me 78 plus 50. So I have 128 equals 78 plus 50 gives me 128. All right, and that is correct. So I know my answer was correct. All right, let's look at example number 5. Here, I have on my left-hand side, I notice that I have some things in common. That this negative 4x can be combined with the positive 12x. And if you remember from combining like terms, the sign in front goes with the term. So I have a negative 4x and a positive 12x. If I just come over to the side, negative 4 plus 12, my signs are different, so I'm going to subtract. 12 minus 4 is 8. Take the sign of the larger number, so it is positive. So this becomes 8x. Bring everything else down, minus 4 equals 36. Now I can do my two-step equation. I notice that is not a special case, so I know I'm going to either add or subtract first. In this case, they are subtracting 4, so I want to do the inverse or the opposite and add 4 to both sides. These 4's cancel out, and I'm left with 8x equals 36 plus 4 is 40. Now I notice that x is still attached here to an 8. I notice that they are multiplying 8, so I want to do the inverse of multiplication, which is division. So I want to divide both sides by 8, and that gives me x equals 40 divided by 8 is 5. Now, if I were to check this answer, I'm going to look after I have combined like terms. So my two-step equation was 8x minus 4 equals 36. So I want to plug my answer in of 5. So I would have 8 times 5 minus 4 equals 36. 8 times 5 is 40. Minus 4 equals 36. Oops. 40 minus 4 gives me 36. So does 36 equal 36? It does, so that I know my answer was correct. All right, let's look at example 6. It says, your bicycle needs to be fixed. A mechanic charges $40 for each hour of labor. And the new parts cost $35. The total cost of fixing the bicycle is $95. How long did it take the mechanic to fix the bicycle? Now, once you read through an application problem, then let's see what we can pick out. First of all, what is the question? They want to know how long. So I'm dealing with time in this case. I know that the mechanic charges $40 for every hour. Well, the hours is what I'm looking for. So when I write this out, I'm going to say that hours are going to be represented by a variable because it's unknown. So I'm going to put X. You could put H for hours, but I like using X. I know that my new parts are $35 and that the whole entire thing equals 95. So let's first see if we can write an equation. I know that it equals $95, that I end up spending $95. I know that the new parts is a total cost of $35. And I know that it's $40 an hour. So I'm going to write $40 per hour. What does the hour represent? X. So it's going to be 40x plus 35 equals 95. And I'm trying to figure out what this x is. So I'm going to set up my two-step equation. This is not a special case. So I'm going to either add or subtract first, depending on what the opposite is or the inverse. They are adding 35, so I do want to do the inverse of adding, which is subtracting. So I subtract 35 from both sides. These go away. So on the left side, I'm left with 40x equals 95 minus 35 is 60. This 40 is still attached to my variable, so I want to get rid of it. They are multiplying, so I want to do the inverse of multiplication, which is division. So I divide both sides by 40. Over here, that means that these 40s will cancel out, so I have x equals. I'm going to come over to the side. Anytime you have a number or a fraction and you're trying to figure out the answer, you do top dog goes in the house. So I'm going to put 60 inside the house, 40 outside. 40 goes into 60 one time. 60 minus 40 gives me 20. I need to bring down a number, but there's nothing there, so I can add a decimal and bring it up. Now I can add a 0. So how many times is 40 going to 200? 5 times. So my answer is x, which represent hours, equals 1.5, and let's not forget our units, so 1.5 hours, so an hour and a half. So the first thing that you need to do when you have an application problem or a word problem is to see if you can pick out the information, what you're looking for, and then try to set up an equation based on that. Alright, now it is your turn. I want you to pause the video and complete the your turn questions. If you have problems with this, you can go ahead, you can look back at the video or you can look back at your notes to help you figure out how to solve it. Congratulations, you have now completed Lesson 5.